Fantastic. So thank you, Greg, and thank you all for coming this evening. So I'm Dr. Stuart Clark. I'm a visiting fellow at the University of Hertfordshire, a Guardian columnist and author. And it's with great pleasure that I'm here tonight to sit with this distinguished panel to talk to you and answer some of your questions about asteroids and about what we've seen. If I can quickly run through the panel for you. At the end, we have Sir Crispin Tickell. He's a former British diplomat, and he's been particularly interested in the relationship between the environment and politics. In 2000, he was a member of the British government task force on potentially hazardous near-Earth objects, and more recently, he was a key member of the Association of Space Explorers International Panel on Asteroid Threat Mitigation. Next to him is Debbie Lewis, MSc. She's a fellow of the Emergency Planning Society and director for Resilience Preparedness at Axiom Alderney Limited. Her work is focused on creating and delivering exercises in relation to asteroid impact events. Next to her is Professor Richard Crowther, and he's the chief engineer at the UK Space Agency. Richard leads the UK delegations to the UN committees dealing with space. He's currently chair of the Interagency Debris Committee and was formerly chair of the UN Working Group on NEOs. Immediately next to me, on my left, is Professor Lord Martin Rees. He's the Astronomer Royal and a cosmologist at Trinity College, Cambridge. Between 2005 and 2010, he was the president of the Royal Society and is a founding member of the Centre for the Study of Existential Risk. On my immediate right, Dr. Brian May is an astrophysicist whose thesis work was about studying the debris partly caused when asteroids collide with one another. And he also has a sideline in music. And then we have Professor Alan Fitzsimmons. He's an astronomer from Queen's University Belfast who specialises in the field of asteroids and comets. He's a member of the Pan-STARRS-1 science team, a member of the EU's NeoShield and NeoShield 2 projects, and a member of the organising committee of planetary defence conferences. And then next to Alan is Lewis Dartnell, and he's a UK Space Agency Aurora Research Fellow at the University of Leicester and an author. He works in the field of astrobiology and the search for life beyond Earth. His latest book, The Knowledge, is about how you could reboot civilization after a global catastrophe like an asteroid impact. And finally, of course, we have the man that's made all of this possible, Greg Richters, the director of 51 Degrees North and the founder of Asteroid Day. Now, I'm going to start the panel rolling with just a few questions, but please start thinking, because I will come to you very, very soon. Alan, if I could start with you. Part of the declaration for Asteroid Day is to call for a 100-fold increase in the detection rate of these near-Earth objects. Now, can you place that into context for us, please? Because I thought we were discovering these things pretty quickly already.
So that's right. So as we sit here today, we've got almost 13,000 near-Earth objects now in our catalogue. But there's a lot more to go. And I can phrase this very briefly in terms of good news and bad news. So let's start with the good news. The good news is that the majority of large near-Earth asteroids have been found by astronomers. Not all. We're still looking. We're still hunting for them. But out of all roughly 1,000 or so near-Earth asteroids that would cause global devastation if they hit, we've got over 900 of them now. There's still some left out there, but that's the good news. We're well on track to finding them. The bad news is that there's a whole bunch of smaller guys out there, and we're a long way off from finding them. And so, although we've got almost 13,000 near-Earth objects, in our books. If we want to go down to the size of the Chelyabinsk impact, the one that you saw at the beginning of the film that hit Russia 2 years ago, we need to have 10 million or more on the books, because that's how many there are. And so we really do need, or we should have the goal of increasing the numbers on our books by a factor of 100.
Lord Rees, if I could bring you in here. This all sounds like pretty gloomy, depressing stuff. How much risk is associated with asteroids in comparison to, say, climate change or pandemic flu? And what do you think is a sensible level of investment every year into this problem?
Of course, it's not the biggest threat that keeps me awake at night, but the good thing about asteroid risks are that they can be quantified, and within a few decades we can do something to reduce them by nudging their orbits, etc. To put them in perspective, the biggest risk actually comes from the rare big one. There are a few chances in a million that we'll die because of an asteroid. And that'll be because in the next 40 years, when I guess most of the people here would otherwise be alive, one of the really big ones might hit, the kind that hits every million years or so. That's actually the biggest probability. But of course, the smaller ones can cause local devastation depending on where they hit. And in my view, it's worth a sort of global insurance policy premium of a few $100 million a year in order to do all we can to reduce the risk, which we can do by, in the short run, as Alan said, trying to survey the sky for the several millions, which are big enough to cause serious devastation, and to think about ways in which we could deflect one of those if one seemed to be on a collision course.
Thank you. And Richard, this threat from the near-Earth objects, this is not just one country's responsibility, is it?
No, can you hear me? Yeah, great. No, so Crispin's task force report recognises this as a global threat that's required an international response. So we've taken this to the UN, and if you have any pens and paper with you, if you want to Google IAWN and SMPAG, there are two UN groups, or two UN-led groups, looking at searching for asteroids, but also developing responses to the threats.
You mentioned there's Crispin's work, so if I can go straight down to the end there. You've authored a number of these reports about the asteroid threat over a number of years now. What is it that's driven your continued interest in this problem?
Well, when I was a student, I studied history, like many other students, and I got used to wars and the usual things that happen in history, wars and kings and queens and battles and so on. But this, like one or two other things that affect the human species, is a change of perspective. It shows the human vulnerability among other forms of life on Earth. And for that reason, I think it gives a wholly new way of looking at the past. So those who are looking at history must realize that there are catastrophes, like the one that hit Chicxulub in Mexico 65 million years ago, and undoubtedly contributed to the end of the dinosaurs, and those that have done other things since then, some good, some bad. And when I was on the task force, we went around the world looking at craters and just trying to wonder each time what the effect was. But I think the vital thing for us to think about today is that this is a new perspective of the human past, and it certainly could be a new perspective on the prospects for life in the future. And that is where I think that the future research must center itself, so that we understand better what could happen by better understanding what did happen.
Now, Brian, when I was with Greg yesterday, I said to him, what was the moment at which you knew that Asteroid Day was something that can happen? And he said to me, it was the moment that you said, let's do it. So it has been a phenomenal excess. In the run-up to Asteroid Day, there has been articles and interest. There's now scores of media articles about this, many dozen events around the whole world. It's been trending on Twitter today. Has it taken you by surprise how much interest there has been in Asteroid Day?
Yeah, I think I'm quite amazed at the extent. I mean, this is a very short period of time to build up a response, and a lot of it is due to Greg's vision, but also I would say what we're seeing most significantly is a team effort here, and that's perhaps what was lacking. There were people, and there are people around the world looking at this problem and doing something about it. But what's happened here, because of Grig and his vision and his film, which he's actually donated to Asteroid Day, is that it's becoming Team Asteroid, if you like. And the power of a group, the power of a team, is so much greater than the sum of its constituents. You now have, sitting at this table, this immense amount of skill and talent. And we are looking at tables like this all around the world at the moment. So suddenly, there is a team effort instead of just people beavering away on their own. And there's a realization in the public which is fueling this to happen more and more. So I think, yeah, I am shocked at how successful it's been. And I think it's it couldn't have happened 20 years ago because there was no internet. There was not this speed of communication. This has grown at an amazing rate. And yeah, I think that your question was I shocked? Yes, I feel quite shocked in a very good way.
Mm. Thank you. So, Greg, let's turn to you then as the driving force behind all of this. And tell us about the moment that you became interested in the asteroid threat and what's driven you on with it these last years.
Well, thank you, Stuart. I think the moment really was, because I'm a filmmaker, I have no scientific background. I mean, I'm really shouldn't be sitting at this table with these amazing individuals here. And the moment I knew or I got fascinated was really when I watched this BBC documentary, actually, The Good, the Bad, and the Ugly. And before that point, this was back in 2010. And before that point, I had no interest actually in asteroids. I thought like everybody else, Bruce Willis sits around and when you need him, you'll call him up. Unfortunately, that's not the case, I realized. So that's why we're sitting here today. And no, that was really the moment. And that kind of like in the film, it really, I just got obsessed, and I had Moritz and Dolly Ann. Who really kind of from the day one really helped push it with me, and here we are today. Hopefully, in a team effort. And I want to say this one thing. I mean, the sort of like, I'm the founder and all that stuff. But really, like, it's so many people here that worked so hard to get Asteroid Day in such a small period of time to where it is today. And a lot of young folks are actually in this room that did an incredible job pulling all this off. And there's some folks in the States, and everybody here at the table. Thank you so much for being here. And so it's not just somebody sitting at a computer and coming up with crazy ideas. It's actually an incredible, hardworking and small and dedicated team that has gotten us to where we are here right now. And hopefully this is the beginning of something wonderful, and hopefully this is the beginning of us, as a global effort, coming together and solving this problem, once, because it is actually something that we can solve, and that's the beautiful thing about it. And all we just need to do is work together. Don't fight each other. Just work together and solve it. Let's do it.
Thanks, Greg. Now, in the film, we saw at the end an absolutely devastating impact. There are other impacts that may not have such huge global catastrophe effects. And it's this point that I'd like to bring in Debbie, because she is the brave person that's been studying what we do if deflection attempts fail.
Well, in the unlikely event of a failed deflection attempt, One of the things that I noticed from my research, that the National Academy of Sciences, in their report in 2011, basically mentioned that contingency planning was an absolute fundamental element of any response to an asteroid impact event, for that very reason, that were, sadly, deflection attempts made in order to deflect the asteroid away from the Earth's orbit, if they were to fail. And as we saw in the film towards the end of it, that sadly no humanitarian response arrangements had been made for civil protection. And that's my field of speciality. I've been working in the field for some considerable time, since 1999. So it's something that I'm very keen on, to see that plans start to put in place for effective evacuation. What we don't want to see is sort of the images of Hurricane Katrina, where people sort of rush to their cars, grabbing, various family members' pets and various sort of family heirlooms and bits and pieces, and making a sort of a bit of a desperate mad dash. Ideally, what we need to see is that if people have got a considerable amount of warning time, and they're informed and advised about the potential hazard from these asteroids, then people can make their own plans and they can make their own arrangements. And certainly sort of organisations need to start thinking, and authorities need to start thinking about what effective arrangements they could start to put in place, which effectively are proportionate to the scale of the risk. And that adds to the sort of the complexity of it, because there's not just one type of impact effect from an asteroid incident. There's a huge raft, and of course that's linked to the size of these objects as well. So planning for such an event isn't quite straightforward, and hence we need the time in order to put plans in place that are effective, irrespective of the size of asteroid that may come our way.
Well, we've been giving asteroids a pretty bad rap this evening. Now, here, to put the other side of the story, is Lewis, because asteroids don't just offer bad things, do they? They can offer some good for the future of humanity as well.
I feel I'm the lone voice at the table here. Yeah, so in my field of astrobiology and the search for life beyond Earth, it's also about understanding the history of biology, the history of life on our own planet. And as we already mentioned, the big catastrophic events that have impacted the Earth. And the old joke is that the asteroids are nature's way of testing how good your space program is. And 65 million years ago, the dinosaurs had a pants space program. So we'd hope to do a better job with ourselves. But as I mentioned in the film, in fact, in the interview, asteroids have also done some good stuff for us, and particularly in the very early Earth's history, when the planet formed relatively dry, it was asteroid and comet impacts that delivered the volatiles, delivered the water to fill our oceans. So we are here because the Earth has been pummeled by asteroids. We just want to stop it happening anymore now that we've built our cities and our civilizations. But if we look into the future, these asteroids, and particularly the ones which are near to us, could offer a good opportunity as well. And when we're developing the technology to rendezvous with these asteroids and maybe deflect them off their impact course, there's very similar technologies we would use to rendezvous with an asteroid and mine it and get valuable metals and volatiles, things like water or organic molecules we could get out of asteroids to bootstrap space exploration and building colonies and human settlements in space. So I thought I would put a single positive spin on asteroids. Once we've solved the problem of how to not get wiped out by them, we should also be considering the opportunities that they offer us, I think.
Okay, so now it's time to open it up to you. So please raise your hand if you have a question. The first person was down here. So, Greg, how are we doing this? Are we inviting people down, or we're letting them grab everybody? Yeah.
Good evening.
Greg Smye-Rumsby will now give us
Thank
a
you
song.
very much, Stuart. It's interesting. We've got all these sort of astronomer-based people here. You've probably been watching the news about Greece, haven't you? Yes? Say yes. Yes. Good, okay. You can see how quickly things become a little muddled, especially in the financial markets. And it doesn't take long. hiding one of these impactors from us isn't going to be possible. Amateurs scan the skies probably far more than professionals. And I think on the way to the Earth, I think we're going to stop paying our mortgages. What do you reckon? If you know it's on its way, you're not going to pay your mortgages, you're not going to pay your bills, the supermarket shelves aren't going to be filled. There's a problem. Get shotguns now. Now, the reason why I'm saying all of this is because I think we need to put in place a recovery program. And the quickest recovery program is to approach the financial sectors because they want to protect their future. And if we want to fund some kind of protection system, I think if we approach the financial institutions around the world, I think there's going to be a much easier recovery.
Okay, so let's bring Debbie in there. You've talked about mitigation. What about recovery afterwards?
Well, certainly there is a mechanism called reinsurance, and effectively it's looking to insure against an asteroid impact event or other natural hazard before the event occurs. It's rather than sort of as has happened in Australia after the floods that they had in 2011, that the taxpayers end up having to pay for it after the event has occurred. And this very much links back into Richard's point about the international response, that really this needs to be something that is looked at from an international perspective by international finance companies and insurance companies, because there is a way, as has been pointed out, that you can start to financially reduce and minimise the effect financially that has globally. Because whatever happens, if it hits in one country, it will have a ripple effect, it will have a knock-on effect. And as we saw from the film, that it can have a number of destinations where it can hit. It was the United States, it was Canada, and of course it was London. So there's huge financial markets there. So it has a huge impact. So yes, it's ideally this is a subject that I would like to see raised at one of the G8 summits or the G20 summits, and that's one of the things that should be discussed now.
So, Crispin, you want to come in there?
Well, I agree with what you just heard, but I would just add this, that what we really need is not just money, as we need leadership. Someone who's ready to make this a cause which is worth defending and worth promoting. That's what's so nice about this event tonight, when we've seen some leadership. Now, all I remember is, if I can tell a little name-dropping tale, is that I was once with a Prime Minister who should be nameless, and I was saying you must put some more money into all this so that we can cope with the kind of hazards that we've been talking about. And he said, well, I don't think the Treasury would ever accept that. And I replied, but you're Prime Minister. And I think it's still very important that, in fact, you should have people at the top who are ready to give leadership, put together the international perspective, make the United Nations jump as it certainly would be willing to do, to bring out programs and to do the right things, do the things that we need done. And all those were in the recommendations of the task force report that I was involved with 15 years ago, where we just said, you've got to do this, you've got to do that, you've got to do the other. And each time the government replied, well, we'll do our best, but it never came out quite sufficiently. And so you need leadership, and with that leadership, you need money to support the research and the actions that are necessary.
Right. Other questions? Was there a question there was a question here in the front row. So, here we go. We have a roving mic, so you don't need to.
Hello there. I never thought I'd get the chance to address the Astronomer Royal and Dr. May on the same table. That's amazing. We've seen that there is no Bruce Willis. We're not going to get the Starship Enterprise. And I've read the stuff about NASA looking at nuclear technology and also some form of tractor technology to change the trajectory of asteroids. How far are we really away from that working? I think that's my question.
I think if we ask Richard to go with that one.
Great. As I said, if you look on the website SMPAG, or if you Google that, you'll see that we're looking at a range of solutions depending on the nature of the threat that arrives. But it looks at gravity tractor, it looks at kinetic impactor, it looks at potentially nuclear in the future. but it's trying to tune the solution to a particular threat. So we need to understand the nature of the threat, first of all, have a rogues gallery, which we can then address our solutions against. But you're right, we need to test the technologies, we need to test the techniques, so that when we need to use the systems, and it may be in 100 years' time, we have some confidence that they're going to work. We don't have that confidence currently, but we can piggyback on the existing science missions to demonstrate some of these technologies in advance.
And thank you, Alan.
Yeah, I'll just follow on from Richard there. I'll just point out that there have been many studies of these deflection techniques that have been done. We've just finished a study in the EU called the NeoShield project, where we actually went into some depth in the capabilities, both theoretically and currently what's available, with both nuclear blast deflection, gravity tractors, and kinetic impactors. And on the US side, that's been done too. And it's interesting that right now there's a fairly advanced proposal going in jointly by the European Space Agency and NASA called the Asteroid Impact and Deflection Assessment Mission. And that's still in what we call a Phase A study, where we're still basically looking at the numbers. But if they work out, and it looks like they are, then that may proceed through the funding if routes can be identified at the end of the year. Because, as Richard was saying, we've got a number of deflection technologies on the table. We've never tested any of them. And given that we really don't want to test the nuclear one first, I think we'd all agree there, then it turns out the kinetic impactor is basically slamming a spacecraft into an asteroid and nudging it into a slightly different orbit is the one really we'd like to go for first. So fingers crossed that may be advancing in the very near future.
Okay, I'm going to come over to this side. Who's got a question over here? Oh, you're a shy side. Okay, in that case, gentleman in the second row there.
Thank you. May I ask, we've gone through the idea of deflection, etc., through the size. What size do you believe that we have to accept that we're going to get wiped out? What size an asteroid coming towards us or object do we have to accept that this is it? A natural occurrence is going to happen. We have a small object in the entire universe. Really, we are completely an insignificant part of the universe in some ways because we don't know what's completely out there.
And Martin, I think, is the founder of the Centre of
Right.
Existential Risk. You're
Yes.
well placed for that one.
Well, I guess it depends how far in the future you're prepared to look and how much you're prepared to extrapolate technology. But I think realistically, within this century, we are only going to be able to deflect the ones up to, say, 100 meters across. And they're the ones that impact once every 2 or 3 centuries. I think in the long run, maybe we can do better, but at the moment we can't do better than that. I'd just like to add one thing which hasn't come up, and that is that when we have the orbit of an asteroid, we can predict where it will land on the Earth, and the sort of error region is a very long, narrow strip with about 100 miles and maybe a few thousand miles long. You can predict where it is. And if we are going to consider what the effort's going to be to deflect it, my worry is that will depend on what part of the Earth it's going to land. If it's going to land in Europe or North America, there'll clearly be huge efforts. If it's going to land in some poorer or less populated part of the world, then the effort's going to be less. And so we do know where it will land, and that's why evacuation is the obvious one. But if we're going to try deflection, then I suspect that the effort put into attempted deflection will depend on where that particular error strip happens to be.
Thank you. Who else has got a question? Come on this side. Yes, look, there's one there. Gentleman waving in, looks like a blue shirt. You've got to run right up the back there.
Had to be a guy at the back.
Round of applause.
It's almost as far as the asteroid belt. My question is about how to link the positive and the negative sides here, because we all know the difficulty of getting humans to make decisions to avoid catastrophes before they fail. You only need to see the global warming denial movement to know that. You're going to cop the same thing. But it's not possible to make money out of global warming, but it is potentially, as the second person from the left was saying down here, to make money out of asteroids. So what's the odds of getting the commercial side of the world, the Elon Musks obviously, but others, to go into the potential for mapping asteroids as part of the effort to try to exploit them commercially?
Indeed, yes. Let's start with our resident asteroid hugger, Lewis.
Yeah, I position myself fairly weakly then, I think, isn't I? So I can't really speak for the economics of how we'll pull people together to send these missions to asteroids to mine them. Just a mountain-sized lump of metal and rare earth minerals and platinum and things will be worth an enormous amount of money and therefore a big target. But something I would like to say to your point is how we tend to be bad at addressing long timescale problems such as global warming, because it doesn't happen on the 4-year timescale of the next general election that politicians tend to think in. But there is another and better example of when there was a big environmental challenge which we stepped up to the plate and we solved effectively, and that was the emission of CFCs in the ozone hole. So, yeah, I think there's reason to be a bit gloomy about global warming at the moment because we are in a bit of a mess. But we've got reason to be optimistic as well, and I say we should look back to our dealing of CFC emissions in the ozone hole as to how the world can pull together and get international agreement, which was uneconomic at the time because more expensive alternatives were picked up, and we would have to draw upon similar resolve for solving climate change and for deflecting an incoming asteroid if we see it.
So, Richard again. Yeah.
Thanks, Stuart. It's probably worth making a name check for Planetary Resources, which is a commercial firm looking at the possibility of mining asteroids. So their founder is Peter Diomedes. He's not quite in the same league as Elon Musk, but he has lots of money to throw at the issue. And he's very keen to demonstrate some of the technologies that we will need for deflection in his missions. So it's happening already.
And Brian, I'd like to just bring you in here as well, because you've devoted quite a lot of your time recently to campaigning, to trying to get ideas onto the agenda. So as well as just getting private enterprise and businesses and all the countries together, is a key part of that just the groundswell of support?
Yes. I find myself sitting here... probably not answering your question very well, but bringing up the subject of money is quite strange in this situation, and it seems to me you're looking at prevention in the beginning, which means detection and deflection possibly, and then if that fails, you're looking at trying to mop up a disaster, and it seems to me there's a very good case to be made for pumping the money in early, because you don't want to be in that last scenario, because you've already got massive loss of life, which no amount of money can fix. So it does seem to me that we're asking people to invest in this quick. We need detection to be ramped up right now and to be working on the solutions of deflection or whatever they are. Otherwise, we find ourselves in a mess which really cannot be fixed by money.
Another question from the audience. Oh, straight there he was. Look, he was very... oh, now you've got to come down. Yeah. It's easier coming down. This one is the last question, so the onus is on you to make it really hard.
Hi. So I'm just interested to understand some of the technical challenges with regard to this number of 100 times, better quantification or whatever of objects that are out there. I imagine they're quite considerable, so I wonder if you could talk to us in a bit more detail about that.
Okay, well, the first person I'm going to ask is Greg at the end there, because it's your declaration. What drove you to that 100 times figure?
I actually have to say, I can only repeat this. I'm a filmmaker. I'm not qualified to really go into that. That declaration actually was something that I wasn't responsible for. I wish I was. No, Rusty Schweikart really put that together with some incredible folks and very thoughtful. No, sorry, I can't really answer that question, especially not surrounded by these incredible individuals. I think I'm not qualified.
Okay, Alan, would you like to help Greg?
I could say something, but it wouldn't be qualified. I'm sorry.
Okay, so let me put this in context. Let me show you. Sorry, can you hear me? Yes, that's it. So let me show you what the problem is. So from my pocket, I'll produce a piece of asteroid. This is a piece of the Chelyabinsk impactor that hit Russia 2 years ago. Now, if this is going out there past the Earth, we only generally see it by the amount of light it reflects. This is a pretty small lump of rock. It doesn't reflect much sunlight. It's pretty dim. Haha. Here's a much bigger one. This is much bigger. It reflects much more light, and so it's easier to see. Now, of course, there's also a distance effect here. The further away from the Earth the asteroid is, the harder it is to see, the closer it is, the brighter it is, the easier it is to see. So we're limited by the size of the asteroid and how close it gets. And that's what we see in today's search programs. We're very good at picking up these large asteroids when they're quite distant. We're very good at picking up small asteroids when they're close by. The small asteroids far away, we cannot see. They're too faint. So there's a number of things you need to do. First of all, you need to increase the size of your telescopes, and that's what's been happening over the past few years. Right now, the most successful telescope is the Pan-STARRS-1 telescope on Hawaii. It's going to be joined by its twin later this year. In fact, under test, it's already discovered some new near-Earth asteroids. If you look towards the beginning of the next decade, the UK is part of a project called the Large Synoptic Survey Telescope, and this is going to be one of the largest telescopes in the world, and it's designed specifically for surveying the night sky. It's got a huge mirror, 8 meters across, and there we'll really start making a dent in this catalogue of sub-kilometre asteroids, building up towards this 100 times increase that we need. Further on, we're hoping that we may be able to use a different type of telescope that we can't use on Earth, an infrared telescope. Now, NASA is studying a concept at the moment called NeoCam, and there's actually a private company as well, a private foundation called the B612 Foundation that are pushing a rival concept, but it's doing an infrared space survey telescope called Sentinel. Either of those projects would again really start making a dent in this factor of 100 we'd really like to see. Even if we get all those facilities launched, it takes time, because these objects take years to go around the sun. It takes years for them to come close enough or bright enough so we can detect them from Earth. So we normally talk about achieving these goals on timescales of a decade or two. But the future is not so gloomy. We already have funding facilities on Earth. We may have some in the near future in space. And it could be, but say by the middle of the 2030s, that we're approaching this 100 times goal. But it's not assured at the moment. Some of those facilities are not funded. And that's what we've got to continue to push for.
Actually, because that question was actually meant for me originally. Okay, sorry. No. I'm not qualified to sit here and talk about numbers. But what I do want to say is, it's not really, at the end of the day, it's not about numbers. I mean, because numbers is something, obviously, the scientists may disapprove, but at the end of the day, it's an idea. It's the idea that there is a problem out there which we know far too little about. And we've got some of the brightest minds, working in this field. But, it comes down to things like funding, which is limited. And really what Asteroid Day tries to do is, give these incredible individuals that are working day and night, that are actually worrying about this problem day and night, giving them an opportunity to, to increase awareness, to get all of us thinking about it, to understand that, you don't need to worry about it, I don't need to worry about it, but give these guys a chance to, do their job. Give these guys a chance to, help us save ourselves, from these rocks in space. And that's really what it's about. It's about raising awareness. It's being better educated about it. It's not about panicking. It's not about all the doom and gloom. It's, I know the movie is a bit doom and gloom. Just a little bit. It's all happy and we're sitting here, right? No, but at the end of the day, there is a global problem, and we are probably the first species that can actually go out there and fix it and solve it. And that's the beauty about the problem. Because isn't it beautiful that there's a problem and we can actually find an answer and we can solve it? And that's really it. But we need better awareness and we need more money, right?
Thank you, Greg. So the take-home message then for all of us is this is not a problem for you to be losing sleep over. Neither, however, is it a problem for you to walk out of the theatre and then not think about anymore. And as we study these asteroids, these comets, these primitive objects that date from the beginning of the solar system, every piece of knowledge that we gain which allows us to protect our world also tells us about the origins of our planet and us, life itself. So thank you ever so much for coming this evening, and thank you to my distinguished panel guests here. It's been a real pleasure. Thank you.